On today's episode, I have Pascal Gallo. He is the co-founder of Composite Recycling. He's joining me today. We were originally supposed to talk at JEC last week in Paris, but schedules got pushed back. We didn't have a chance to get him by the Composites Weekly booth for the interview, but we were able to schedule a time after the show to have him on because they made some really exciting news last week at the show, and we'll be talking about a joint collaboration that is really going to be great for the marine industry. We had, I guess, probably a couple of months back, we had Guillaume Perbin. He is the CEO. He joined us and just talking about their recycling technology. And if you can see, if you're watching the video, I have a picture up on the screen to show. And these are actually out in the field right now. And Pascal's joining me today to talk about that. And also this new alliance that they're having with a number of partners, including Veolia, Arkema, Owens Corning, and also Beneteau. So, Pascal, thanks for joining me on the podcast today and spending some time and sharing this latest news and announcement.
Thank you for having me, Jonathan. It's a pleasure.
So before we get into some of the news that you guys, you all announced last week at JEC, I've got a picture up. If you could share some of the latest on the technology. It's currently out in the field right now. We were talking before the show, doing about 400 tons, over 400 tons. Is that correct?
That's correct, Jonathan, actually. So the machine was built by Fiberloop. It's a company based in Sweden, and it was commissioned there in Sweden. The first tests are really conclusive, and it was delivered in December. On the site in Veolia site. There's a partner, the Alliance, in France, in the north of Nantes, which is a city in the west of France. And as you said, it's capable of treating 400 tons per year. We count 2 tons per day over 4 cycles. Say a single batch is 500 kilograms. So you see, depends very much on the kind of material that we treat, but on average, this is based on polyester-based composites, 50% glass fibers, 50% polyester. But of course, it works with a variety of material, including carbon fibers, using the same parameters, and of course, helium, which I think we'll talk about later in the show.
Yeah, and you're using the thermolysis recycling solution in this process. And do you have more than one of these units out right now, or is this the initial unit?
This is the initial unit.
Okay.
We have smaller systems in Switzerland who performed over 450 tests over the last 3 years.
Okay.
Thanks to those smaller units, we managed to define the parameters that will work for composites in this larger unit. So, but this is really the first industrial scale system that we have, that our company is operating. Absolutely.
So let's talk about some of this announcement. So I know it was unveiled last week at JEC, and so we're kind of a week after. But you're continuing to push the boundaries of circularity, and in this way towards the marine industry, and in composites. So you've got major industry leaders that you're working with to join forces within the boat manufacturing arena. And I guess it's for the first time boats can now be built using recycled and recyclable materials. So if you would share a little bit about the announcement and what this means for the marine market.
So first of all, we're really, really grateful to be part of the alliance, because if you consider the size of the companies involved, actually we're much smaller than the other companies. So, we're a startup. And this is why actually we're really grateful that those companies trust us to be part of the loop. So I think it can start from Benetto's manufacturing boats, and they started with the first 44, then the Sunfast 30, then the Oceania 60, and they really pioneer in the sense that they were among the first to use Arkema's resin, the helium resin, which is
the helium.
yes, PMMA based. What's specific about the resin is that when you do the thermolysis of helium, you go back to the initial monomer, which is methyl methacrylate. And the advantage for us is that we operate at a much lower temperature than for the other polymers, so epoxy and polyester. Typically, we operate at around 350 degrees Celsius, so we save a lot of energy. And we typically obtain a purity of around 80%. So the recovery rate is pretty high, actually.
Wow.
With this helium resin. And I know it was quite challenging to change the process internally to manufacture composites, but somehow it's manageable. And Beneteau managed to industrialize the composites made of helium. And so this is, let's say, on the polymer side, you see of the loop. On the glass fibers side, we're again very grateful that Owens Corning trusts us to provide the fibers. So then the challenge, as Owens Corning is remelting the fibers, the challenge here is to come up with fibers that are clean enough to be melted. So very little concentration of organic residues, and this is why actually our process works well. To provide the fibers with a sufficient quality to remelt. And Owens Corning then produces the fibers that are woven by Chomarat into fabric, and the glass fibers then go back to Beneteau, combine, let's say, the recycled helium with glass fibers to manufacture new boats. And at the center of the collaboration is Veolia. Veolia is there for the logistics, essentially, so to collect the waste and sort the waste. And this collaboration with Veolia gives us a lot of credibility in the space, because I guess that taken separately, it would be hard for such large companies to trust a small startup like. So yeah, very grateful to be part of the both loops, fibers and plastic, and it's a game changer for the industry. So we're very strong advocates of Arkema's helium resin, but also we think that Owens Corning's solution to remelt the fibers is a very good option. I must say, because you really go back to the original quality, the fibers, and then you address the challenge of putting the sizing back on the fibers in this way. So provided, and that's what they're doing, provided you source your energy to remelt the fibers from a sustainable source. So they take electricity from a dam, basically. So the impact, they share the carbon footprint, and it's very low, very light. Cannot provide the exact number, but it's incredibly low. So providing that, it's a perfect way recycling the glass fibers.
I'm curious, when will this be tested? I assume it would be at one of the Beneteau manufacturing locations.
Well, we started collecting the waste actually from Beneteau, so they already used dozens of boats, and we're now focusing on the production scraps. So because the helium is pretty new, so having objects, that have reached the end of their useful life, it's not very straightforward. It's new material. So we're focusing on production scraps, and the advantage for us is as well that these are materials that are very well known since it's very easy to trace them, you know. So
Sure.
the collection has already started, and as we speak, the material is already on our Veolia site. And we are about to treat the composites. So I would say that next month we'll start treating the material provided by Beneteau, and this is after a series of tests we made over the past few years, a couple of years, I must say. Where we proved that indeed, actually, as I said, actually we could reach a purity of 80% of methyl methacrylate. So
sure.
So that's the first part, and I know that there will be developments as well on Owens Corning side, and the time scale is more or less similar with an actual industrialization by the end of the year. By the end of 2025.
That's great. Once they're separated back into their, I guess the virgin fibers and in materials, is the plan to go back and reuse a lot of these in their production process?
Yeah, that's the plan. So the missing link, I would say, on Arkema's side is to purify the analysis oil. So as I said, actually, there is 80% on average, 70-80% of methyl methacrylate, and somehow you need to purify this to up to 98% plus. So, and I know that they intend to do this with the distillation process, but they have all the capacity and the know-how as well in-house. It's a major chemical company, so. And then once it's purified, so you need to remanufacture, reformulate helium that will go back to Beneteau, so to close the loop. And we're talking about manufacturing scraps, but somehow this is replicable, and you can use exactly the same process when the boats will have reached the end of their useful life, you know, down the road. So 30 years from now, it's exactly the same process that is going to be used. Yeah.
Right. There's got to be a lot of cost savings there for manufacturers out there who are looking to adopt this process.
I would say rather than cost saving, it's visibility. Visibility on cost. So first of all, on the landfilling side, we don't know exactly where prices will go. And at one point, landfilling will be banned. I can give you an example of Austria that has adopted a law that was voted a while ago in the 90s at the European level. So there in Austria, it's completely banned to landfill composites. And basically you kind of lose your freedom to operate, you know, there.
Right.
And so it gives visibility on the continuation of the operations. Then visibility on the price as well of the commodities, because we're not bound to the price of oil, crude oil. You know, when you recycle, then your your base material is plastic. It's not oil. So it gives you, let's say, it decorrelates the price of the plastic from the price of crude oil.
Right.
So I would say, rather than immediate cost saving, it's the visibility on the pricing and the assurance that the prices will not go up. You know, that's very important.
Yeah. How can, our listeners, is there anywhere, I guess, over at the Composite Recycling, they can learn more about this? Or you mentioned Owens Corning or some of these partners that are collaborating. And then I see some of your updates on LinkedIn over at the Composite Recycling page. What's the best way that our listeners can follow up on the progress of this?
I think that so Wendy is doing a great job, at her website, and she's doing great. So I think staying tuned. LinkedIn as well. She's very active on LinkedIn, represent her company. So LinkedIn, our website, composite-recycling.ch.
Yeah, that's good. We'll post a link on our show page. We've got the website showing right there up on the screen, and cycling down at the bottom. Pascal, I want to thank you for spending some time. Sorry we didn't get a chance to meet at the show, but at least we get a chance this week, right?
Yeah,
glad you made it back. Glad you made it back home safely, and best of continued success for Composite Recycling. And again, thanks so much for joining me on the show today.
Thank you, Jonathan.